For my project, I decided to create a theremin. A theremin is a musical instrument that's played without touching it. It was patented in 1928 by Leon Theremin, a Soviet inventor who was making listening devices to spy on the US government. So it was a project to experiment with electrical fields and how disrupting electrical fields can send signals to a computer. So I thought it would be an interesting project to try because it would be a good way to figure out how the Raspberry Pi works and how to experiment with those commands, but also how to learn some hardware and wiring that I don't have much experience in. So without further ado, here's what I came up with. As you can see, so yeah, pitch, volume, pitch, volume. And so I have these two speakers hooked up to it. Right now I have it hooked up to a monitor so that I can run the code. I'll explain the code more in depth later. But the goal is to get it so the program runs entirely without me having to open up a monitor, so I can just bring it places and not have to worry about it. It's just all in this cardboard box that I poked holes in so that the wires wouldn't come out. So here's what it looks like inside. I have the two ultrasonic distance sensors hooked up to, hang on a second. There we go. I have the Raspberry Pi here. I have it connected to these pins, and the pins are ground, power, and the outlater. This is the circuit. It's pretty simple. It just takes in the readings from the ultrasonic distance sensors and puts it into the circuit. Uses some resistors to keep it from blowing up, I assume. And yeah, I mostly copied the tutorial from the Raspberry Pi website, but there was quite a few changes. Now, this isn't the first design that I had. This is actually the second, and it's not going to be the last. Right here, I have my first prototype, which is much more fancy, but I had to. So for this one, I wanted to build a much more realistic theremin, made by building the oscillators, which you can see this circuit here, how much of a mess that is. So this is one of the prototypes. I have the antennas for it, and the antenna, it's built to be portable, so you just screw the antennas in these holes here and then take them out when you're done. But yeah, I'm not gonna focus too much on this, but this is the first design for the project where I was going to do a much more complicated version, and I decided to go with a simplified version and work on this later when I have more experience with circuitry. So here are the pins, the GPIO pins for the Raspberry Pi. I connected it, here, back over to my little circuit. As you can see, I connected them to these pins, GPIO 17, GPIO 4, ground, and the power. The ground is for like circuit reasons. Power is also so that the power runs through the circuit. GPIO 17 and 4 are those are for the outputs that the ultrasonic distance sensor takes in readings, and this is where the readings go. After I finish making this the best it can be, I'm going to work on this one, which is much more complicated, but will also be a lot more elegant and efficient. I messed with that for a little while longer before deciding to switch to the simpler version using the ultrasonic distance sensors. So after I picked up the ultrasonic distance sensors, and I had enough parts from trying to develop the other circuit that I didn't need to get anything else. I just had all the parts.
Alright, so here is the Raspberry Pi desktop. I connected using tight VNC so that I could just manipulating using my computer. I have it hooked up to a monitor and I can do that, but this is also a lot easier because I can screen record here. Alright, so let's take a look at the code. There are two programs that are running here. There's this, which is the Sonic Pi software that actually helps output the sound. So it's just a loop that runs the notes and it plays these servers, and then it just plays the notes, and we'll go back over to the other program, which is the more important one. Here's the other program. As you can see, it's reading in values. It's reading the volume distance, and if I move my hand, you can see that the volume distance is changing. And if I move my hand to the pitch oscillator, you can see that the pitch is changing. So that changes the note values. This is the other code. I'll make sure to put I'll make sure to put in all the resources in the resource document. So this is another loop. This is just the Sonic Pi script that is in a comment. Then we have the distance sensor and the pins that they're plugged into. So as you can see, sensor volume is plugged into the distance sensor, and it has these GPIO pins connected so that the program knows exactly which GPIO pins to reference. This reads in the values and prints it. This is just so that you can see it on the terminal for debugging purposes. Then it rounds it to a MIDI note value, and that gets the note value. Then it prints the note value, and that's just all the printing stuff, right? And then the sleep is just so that's not constantly going. That's my project. I accomplished some of my goals with this project. I did hope that I would be able to make one with copper antenna, but I'll have to work on that more and just develop that.
Yeah, so there was some changes that had to be made there in the code, and I'll go in detail on those later. But once all that was finished, then I just adapted the tutorial to fit my own needs. For example, the tutorial only used one ultrasonic distance sensor, and it didn't have the box or anything or how to do the speakers, so with a project like this, it's normal to expect problems, but the thing is the problems were very different from what I was anticipating. The biggest one was possibly my lack of knowledge when it came to wiring and circuitry. That was the biggest thing. I just didn't have a good grasp of the basics that I really needed to know. So that took a lot of learning and tutorials and just figuring out how the basic design of circuits and how to read circuit diagrams. But now I can read a circuit diagram, so there's that. There was also the fact that I'm not very familiar with the Raspberry Pi interface. So I had to figure out how to learn from there and just kind of try and experiment with things and figure out how things work. And so that was the biggest problem, was my lack of knowledge when it came to these things. But after learning how these things worked, it was a lot easier to develop the project. The second problem was just that there's not a lot of resources out there for the particular problems I was encountering. For example, there's not much on the tutorial that I was using. It wasn't updated for the current Raspberry Pi interface, and it was just completely outdated. Now, the tutorial on the website didn't have as much information as I would have liked. It didn't have any pictures of what it looked like at the end, or it didn't have any pictures of it didn't have as much resources for what do you do if you're using a Raspberry Pi 4 instead of a Raspberry Pi 3. So the lack of documentation was the other problem that I encountered. And the way I fixed it was just learning what I could and then experimenting. And the biggest problem that really impacted the course of the project was that I couldn't finish the original project in time for the deadline. And that was pretty discouraging when I realized that I couldn't finish it because it was just taking too much time with the amount of resources that I had. It just wasn't working out. So I had to completely switch into a new direction that I really didn't think I would have to do. And yeah, so that's my project for this semester. I'm excited to see where it goes from here because I'm going to continue working on it and seeing if I can get more things to work so I can just use it like an instrument. And yeah, thank you for watching.